Welcome to this Materialize Magics tutorial about file errors. In this tutorial, we will discuss various types of STL errors. An STL file is a file format that can be read correctly by a 3D printer. During the additive manufacturing process, an STL file of the original design needs to be created. Why is a CAP file not sufficient? Because a CAP file does not contain any information about the inside or the outside of the part, unlike an STL file. First, we explain why STL errors occur. Afterwards, a definition of the most common errors will be given. This should lead to a better understanding of each error that is given. This image shows where Materialize Magics is positioned within your additive manufacturing workflow. Magics is the link between your original CAD file and the 3D printed part. The first step, going from CAD to STL file format, is a conversion from parametric design into triangle-based design. This can cause multiple errors. Most of the CAD programs are not developed with a focus on additive manufacturing applications. Aside from conversion issues, design imperfections of the original design also lead to STL file errors. For example, a bad junction of several surfaces, or the result of a 3D scan. These bad conversions and imperfections make it impossible to print your design correctly. The STL file errors need to be solved first, so a fixing is necessary. Due to its long-standing experience in additive manufacturing, the Materialize Magics software is fully equipped to deal efficiently with many of the STL errors, so that the result is one entity of triangles without any errors and is ready for 3D printing. Now that we know why STL errors occur, and before showing how to resolve them, we can take a deeper look at the most common errors and provide a definition for each of them. There are 5 big main categories. The first type of error is inverted normals. Second, and often related to the inverted normals, we have the bad edges. Alternatively, we can have problems with the shells, with overlapping triangles, and with intersecting triangles. Let's go a bit deeper into each of them. So, before we start to print our file, we aim to have an STL without any errors. Therefore, we have to fix inverted normals. These form the first common STL error. In this case, an inverted normal points inwards instead of outwards, and the material is defined to be deposited on the wrong side of the design. A triangle with an inverted normal is called a flipped triangle. A flipped triangle can easily be noticed, since the backside of the triangle will be colored red. These flipped triangles will cause bad edges. In a correct STL file, adjacent triangles should always have 2 vertices in common with their neighboring triangles. If an edge is not well connected or missing neighboring triangles, it is called a bad edge. Bad edges will be visible as yellow lines on your design. The error bad edges can still be classified as near bad edges and bad contours. Near bad edges lay very close to each other, but are not properly connected, and can easily be solved by stitching. Several bad edges linked together in a closed loop form a bad contour. Bad contours can form a hole, but this is not always the case. A hole appears when triangles on a shell are missing. In this case, 3 triangles are missing. Through a hole, you can see the backside of other triangles. It will therefore look red in your design. A third type of error is linked to the shells. A shell is a cloud of uninterrupted triangles. Normally, one part consists of one shell. However, it is possible that your design has several shells. This can be due to noise shells and intersecting shells. Noise shells have an extremely low number of triangles, or have very small volumes. Noise shells often need to be removed, as they can cause problems during the slicing or printing process of your 3D printer. Besides noise shells, intersecting shells form another error. These are shells that partially occupy the same volume. If we don't clean up the intersecting shells, the intersecting volume will be printed twice while printing. This will cause overcuring or overheating of the material. For a successful print, this needs to be fixed. The fourth error is overlapping triangle. Triangles are overlapping if the distance or angle between them is smaller than a given tolerance value. These triangles can often be recognized as a zigzag form in the surface, likely to be less crucial for printability, but we recommend to remove them anyway, since these fixes will improve the surface quality. A last error, which we will discuss, is intersecting triangles. You usually will have these triangles if you have intersecting shells. Triangles that intersect need to be unified. We end with a summary of all errors. First, we have inverted normals. Then, bad edges, which consist of near bad edges and bad contours. Bad contours can sometimes be called holes as well. Furthermore, we talked about problems with shells, and more specifically, noise shells and intersecting shells. Overlapping triangles and intersecting triangles are the last two errors we discussed in this tutorial. To finalize, we will go in the software and review the most common STL errors with their corresponding color codes. The first one is inverted normals, which is indicated as a red surface. That is why the inside of an STL part is always red. Secondly, bad edges, including near bad edges and bad contours, are indicated with yellow lines. Let's go to another part to have a clearer image. This part displays a hole. Holes are indicated with an uninterrupted yellow contour, and you will also see the red on the inside of the part. The other circle has inverted normals, which means you can't see the inside of the part. If you want to learn how to fix these errors, or you want to see other tutorials, be sure to check them out at materialize.com.